I'm extremely sorry for the last mess. I just save it instantly, but I cannot continue with that. Okay, let's start now. Our relations are in the set Z of the all integers defined as x, y, x minus 1 is an integer. So it's okay. Now we have to given that Z is equal to minus 5, minus 2, minus 1. I have started this for minus 5. It doesn't mean that it has started for minus 5. Many more numbers we have got after minus 5, and minus 2, minus 1, 0 up to we could have taken infinity. And the relations x, y, x minus y is an integers. So from integers we could have find the relations like this 0, 0, 1, 1, 2, 2, 3, 3, minus 1, 2, minus 1, minus 1, minus 2, minus 2 up to infinity. Why? Let's see here, because after we have to the given relations x and y, after putting 0 minus 1 0, 0 is also an integers number, 1 minus 1 0 is an integers number, 2 minus 2 integers, minus 1 minus 2 minus 3 we will get, that's also an integers number. So all the numbers we have taken like then minus 1, x value is minus 1 as per formula, then minus sign has came in place of y, again we have to put minus 1, minus 1 minus minus plus, so that's also an 0. Those are the integers numbers we have again got an integers. Okay, those are the ordered pair we have taken. Now see from here 1 1 2 2 3 3, as I said, the same element has repeated, so it belongs to R. It means reflexive. 1 2 is belonging to R. Okay, 1 2 is also an integers. I have not write in here, but it doesn't mean that it does not came under these relations. It will also come, because 1 minus 2 is minus 1 we will get, and that's also an integers. 1 2 belonging to R, that means 2 1 is also belonging to R, because 2 minus 1 and 1 also we will get an integers number. It was also is being come under relationship, so 1 2 belongs to R and 2 1 is also belonging to R. That's an symmetric. And for transitivity, it must for transitivity we know that AB belong to R, BC, then 1 2 is belonging to R, 2 1 is belong to R, because you see some of the ordered pair I have not write under the relations, because I cannot write all the ordered pair. See here, 1 minus 2 is equal to minus 1, like 2 minus 1 is equal to 1. Those are also integers. Okay, so that's 1 2 belonging to R, 2 1 belonging to R. 1 and 1, the first element and the fourth element is also belonging to R. That's why R is also transitive. It's okay. Here I will do I'm going to do only 2 maths from here. I'm going to discuss. Let's see. Relations are in the set A of the human beings in the town. A particular time is given by like this: A is equal to x, y, x and y work in the same place. So we are going to see whether it was reflexive, symmetric or transitivity. So that's what has given. Let's start it. X and y work at the same place. Okay, so x and y work at the same place. It's supposed to be x, it's supposed to be y. They're in the same place, x and y. That's why x and x same. That means it was equal. Okay, so as I said, the same element has came. That's why R is reflexive. Now see, it was symmetric also. Why? Because x and y belonging to R, then y x also belonging to R. Why? Because we know that x and y work at in the same place. When the place was same, we could have then supposed to be it may be y, it may be x. So that's why x y belonging to R, y x belonging to R to symmetric hobo. Next one is also transitivity. Y works at in the same place. It doesn't matter if we have to take an z. If we suppose here I have choose a z. Then x y y z, jodi x y thake y z thake, x z to eketa place ote thakibo. That's why it should be it's been at a transitive. Okay, and for a second one we will get locality. That's the same technique we are going to using in the previous maths. It was also came same locality, same place. That should be say that it must be reflexive, symmetric and transitive. Now I'm going to doing this. The relation has given R equal to x, y. X is exactly 7 centimeter taller than y. So it's a critical maths, and let's start it. Okay, I'm going to discuss this. Yeah, this one. So x is exactly 7 centimeter taller than y. So check whether it's reflexive, symmetric or transitive. So it cannot be reflexive. Why? X and x doesn't belonging to R. Mane x2 to x short koi dangor hobole nuare. It should be equal. But here x is exactly 7 centimeter taller than y. X2 here can x doesn't belong in it. It means it cannot be taller than himself. It to x means it cannot be equal. It to equal hobole nuare. The conditions amak dia ase conditions to ki dia ase x is exactly 7 centimeter taller than y. Y koi x to 7 centimeter taller hoy. But x cannot be taller than himself. X to tat nijor 150 centimeter ko x to nije dangor hobole nuare. So that's why it cannot be reflexive. And let's see here 150 if 7 centimeter has deducted from here we will get 143. It has 143. Suppose it was x, suppose it was y. 143 and it was x is exactly 7 centimeter taller than y the condition has given. So that's why I have write 150 and it was 143. So x is exactly 7 centimeter taller than y. Okay, xy is belonging to R, but y cannot be taller than x. Why 143 to 150 koi dangor no hoy. 150 dangor hoy 143 koi kiman centimeter 7 centimeter. That's what satisfying. X is exactly 7 centimeter taller than y, but y cannot be taller than x. So yx doesn't belonging to R. So R is not symmetric. R cannot be symmetric. And for transitivity, what happened? The same rules we are going to following here. X, y, y, z belonging to R. Suppose 150, 143. After that, again we are going to deduct it 7. Then we will get 136. That's why we have to write here the up to z, because in ordered pair when we will have to write x, y, then yz, we know that if xy is belonging to R, yz is belonging to, so it is necessary xz should be belongs to R. So here is see x is exactly 7 centimeter taller than y. 150 to obviously 142 ke ki dangor hoboy. Next to ki koise 143 definitely 136 shot ke dangor. Y is 7 cm. That's why it was 7 cm. After we have to adding 7 centimeter, we will get 143. So it is satisfying. But x is exactly 14 centimeter taller than z. যদি মই x to z ৰ লগত কম্পেয়াৰ কৰো, ইয়াতে 7 cm, ইয়াতে 7 cm, but এইটোতকে কিমান সেন্টিমিটাৰ ডাঙৰ হৈ আছে? Total 14 centimeter. After we have to adding 14 here, we will get 150, because for transitivity we need to compare x and z, and that's why it cannot be transitive. X is exactly 14 centimeter taller than z. That's why it cannot be transitive. Okay, some of the important needs I'm going to discuss. It's okay. I'm going to discuss this one. Okay, that's question. So let's see here. Show that the relations are in the set are of real numbers defined as like this: R A B A is less than or equal to B square. Is neither reflexive nor symmetric or nor transitive. We need to show that from the given relations. The condition has given. Okay, again I'm going to write the conditions here. So R which is A B A is less than equal to B square, where it is reflexivity or not, we need to show that. See, if we are going to choose half in here in place of a, half is less than or equal to half of square is not true. So half after we will get here 0.5. Less than or equal half 1/4 whole square means it cannot be less than. So that's why it cannot be, it is not true. We know that half less than or equal to half square cannot be true, and that's why it is not reflexive. So similarly for symmetricity, what happened? -1, suppose -1 is less than or equal to 3 square, but 3 less than or equal to -1 whole square, it cannot be 3. We know that 3 is always greater than -1 whole square. Okay, so reverse is not satisfying. -1 to eto thik ase, eto equal hobo noy, kintu 9 to obviously ডাঙৰ হ'ব -1 তকৈ, but -1 to ইয়াৰকে ডাঙৰ হ'বলৈ নোৱাৰে, so reverse is not satisfying. That's why it cannot be symmetry. R is not symmetry. And for transitivity, we can also use the same technique. So you can also choose the others numbers too. So I'm just choosing those numbers. All of you guys can choose own numbers. So you are assuming this, and that way I think if you are going to doing the maths, and it will helping you. Suppose 2 is less than or equal to -3 whole square, -3 is less than or equal to 1 square. Okay, from here what happened? Yeah, definitely it was true. Okay, -3 whole square means this 9 is always greater than 2. -3 is less than or equal to 1 square. Yeah, 1 is always greater than -3. But the first element 2, the fourth element 1, -2 cannot be less than 1. So that's why so conditions what happened, 2 -3 belong to R, 2 -3 belong to R, -3 1 belong to R, but 2 1 doesn't belonging to, so R cannot be transitive. So what the maths has given, it has all true, that neither reflexive nor symmetric nor transitivity. Okay, we are going to do the another maths questions here given. Check whether the reflexive relations are defined in the set 1 to up to 6. R is equal to B, A plus 1, reflexive, symmetric or transitive. Okay, given A equal to 1 2 3 4 5 6, relations are defined like this: A B equal to A plus 1. From here we can choose those values, and choosing those values we can write the order pair. Suppose in place of A, first of all we are going to put 1, then B is equal to 2 value, A value jete 2 put koriba, then up to we can choose it 5, and then we will get 5 6. Let's see here, 6 is belonging to A. Okay, suppose 1 is belonging to A, 2 is belonging to A, 3 is belonging to A, but the same element doesn't belong to R, so it cannot be reflexive. I think already got that point, because I have similar messages I have done many times. It can be observed that 1 2 is belonging to R, but 2 1 doesn't belonging to R. Okay, R cannot be symmetric. Now say here 1 2 belonging to R, 2 3 belonging to R, but 1 3 doesn't belonging to R, so it cannot be transitive. Okay, so that's what we need to show, that reflexive, symmetric or transitive. Okay, whether those are reflexive, symmetric or transitive, but we have it's neither reflexive, neither symmetric nor transitive. Those are the same maths, very easy maths. And okay, let's start this maths. So after this I'm going to stop today. Check whether the relations are in the defined by A B, A is less than or equal to B cube is reflexive, symmetric or transitive. Okay, let's see here, R equal to A B, A is less than or equal to B cube. It is observed that suppose we are going to assume half and half. Half is less than or equal to half cube, less than or equal to ultimately 1 by 8. R is not reflexive, because 1 by 8 cannot be greater than half. Half means 0.5, and 1 by 8 means what? It cannot be. It's a small value, very very small value. So that's why it cannot be greater than. Okay, it was always greater than this, and that's why it cannot be reflexive. Suppose 1 2 is belonging to R, 1 less than 2 cube means definitely it was true. 1 is less than 2, but 2 less than 2 1 doesn't belonging to R. Why? Because 2 cube is greater than 1. 2 cube cannot less than 1. 2 cube always greater than 1. That's why 2 1 doesn't belonging to R. So R cannot be symmetric. Let's see for transitivity. Suppose 3 by 2, 3 by 2, 6 by 5. Okay, 3 less than 3 by 2 whole cube, and 3 by 2 less than 6 by 5 whole cube. But it's okay. You see, 3 less than 3 by 2 means 3 cube means 27 by 8. It's okay. It is satisfying. 3 is definitely less than this value. 3 by 2 is less than this value. After we have to dividing this, you can calculate by yourself, and you will get the value, and that should be definitely it will be greater than this. Okay, and but 3 6 by 5. See here, 3 6 by 5 doesn't belonging to R. 3 is always greater than this value. So after calculate this, suppose 6 6 6, multiply the 6 3 times and dividing this by 3 times. After you will get a small value, which is, that's why 3 is greater than this value. So it cannot be 3. So R is not transitive. Okay, and from tomorrow, once this I think enough discussions of relation and function from the first chapter. So I'm not going to discuss anymore from the first chapter. We'll start from a second unit. I mean second chapter, functions, and one functions, many one functions, many two functions. But once the chapter was finished, I will discuss the first year relations and functions topic also, because we are going to start some of the topic which is related to IIT, JEE Main,